So up to now, the vector examples we've done have all been pretty straightforward, as in right triangles, up and down, and so on. Unfortunately, this isn't always the case, and sometimes there'll be things that are not at right angles, and when it's not, then we have to use a different set of tools, things like sine law, cosine law, and so on. And so here's an example of a harder type of question, one that will actually need something like cosine or sine law to solve. So here we have a bird flying at 28 meters per second heading north. So I'll always start off with the diagram, and that's what I'm going to do here. So we have the bird going north at 28 meters per second, and then the wind going 30 degrees west of north. And so whenever I add vectors, I tend to draw these crosshairs, and they help me see things a little bit better. So this is going something like that, and I don't think I did a very good job with the angle or the scale, but it shouldn't matter because we're calculating things out, as long as you're close. Okay. And that will be our resultant velocity. I can put R for resultant velocity. Okay, and we know the wind is going here at 20. Alright, so the first thing we'll have to do is angles. We have two sides, and we have a third side that's missing. We have angles, and we need an angle in this triangle. Now, by looking at it, sometimes it's hard to see. You have to play around with the numbers, play around with the angles, and then things slowly start coming up. I see that this is 30 degrees, and this is actually a right angle here, if you can see the mouse button move around. So if this is 30, that would make this angle 60 degrees. And I can see this here would be 90 degrees. So as a result, this angle here would be 150 degrees. So if that's 150 degrees, now I can actually start to do something. I can call this side C, and I can do angle C. I can say this is angle A and angle B. Actually, I like going in order. I'm not sure if it always works out that way, but I always try to go in order, so let's just do that. So it's going clockwise, angle A, angle B, angle C, and then opposite angle A, we have side A, opposite angle B, we have side B. So I'm going to use this, the cosine law to solve the resultant velocity there. The cosine law being c squared is equal to a squared plus b squared minus 2ab cosine c. So when we work that out, that comes out to about 46.4 meters per second. Now this is a vector. Velocity has magnitude and direction, so we need an angle. The heading that this bird will go in. So the bird is the red vector here, VR. And so I can give one of two angles. I can give this angle and say that it's going at a whatever angle happens to be north of west, or in this case, the easier way, because we already configure this out as soon as we find the angle of the triangle, I can find out this angle A. And angle A will be just west of north. So to find angle A, I will use the sine law and say sine A over side A is equal to sine C over side C. So angle A will be the inverse sine of A times sine C, because I did some cross multiplying there, over C. So what I did is I multiplied both sides by A, and then took inverse sine of both sides, making the sine disappear on the left, and the inverse sine show up on the right. So angle A then will be inverse sine of side A, which is 20, times sine of 150. Divided by side C, which we just figured out was 46.44107. Notice I kept extra numbers longer. You want to keep numbers as long as possible, and then your final answer you can round off to 3 significant digits, but try not to round off early because it introduces rounding errors. So working that out, angle A works out to 12.443 degrees. So our resultant vector of velocity is 46.4 meters per second, going at 12.4 degrees west of north.